Have you ever wondered what connects a diamond, a glass of milk, and the air you're breathing? They seem wildly different, but they are all part of the universe's grand organizational chart. Welcome to the secret recipe of everything. It all starts with one simple word: matter. Matter is anything that has mass and takes up space. Your phone, your body, the distant stars, it's all matter. And if we could zoom in past what any microscope can see, we'd find the fundamental building blocks of this matter. Atoms. Think of atoms as the universe's ultimate Lego bricks. They're incredibly tiny, indivisible units of an element, but rarely do they travel alone. Most of the time, they link up in specific arrangements to form molecules. Picture this: 2 hydrogen atoms and 1 oxygen atom snapping together. Who's like that? You have a molecule of water, the substance that makes life possible. These atoms and molecules are the characters in our cosmic story, and how they decide to group up determines everything you see, touch, and feel. It's a story of 2 main families, the pure and the mixtures. Let's first explore the family of pure substances. These are the VIPs of the chemical world, materials with a uniform and definite composition. No matter where you sample them, they are chemically the same. Within this exclusive group, we find the simplest of all: elements. An element is a pure substance made of only one type of atom. Think of a bar of pure gold. Zoom in, and all you'll find are gold atoms, stacked together in a perfect, gleaming lattice. It's the universe's most basic ingredient list, found on the periodic table. But what happens when these elemental ingredients are not just mixed, but chemically fused together? You get a compound. This is where the real magic begins. A compound is formed when 2 or more different elements bond in a fixed ratio, creating something entirely new. Consider this dramatic transformation. Take sodium, a soft, silvery metal so volatile it explodes in water. Now, take chlorine, a poisonous, greenish, yellow gas. Separately, they are dangerous. But when they react, they form a chemical bond, giving up their old identities to become sodium chloride. You know it as table salt, the harmless, crystalline substance you sprinkle on your food. That is the power of a chemical bond. It's not just a mix. It's a complete reinvention, creating a new substance with properties unlike its parents. Now, let's leave the world of chemical bonds and enter the more casual, everyday world of the second family: mixtures. Unlike compounds, a mixture is a physical combination of 2 or more substances that are not chemically united. The crucial rule here is that each substance keeps its original identity and properties. Think of it like making a salad. You toss in lettuce, tomatoes, and cucumbers. You've mixed them, but the lettuce is still lettuce, and the tomato is still a tomato. You can, with a little effort, pick them out again. The same goes for a handful of trail mix or the dirt in your garden. You can see the separate parts: the pebbles, the twigs, the soil. This is the fundamental difference. Compounds are about chemical transformation and creation. Mixtures are about physical combination and coexistence. One is a marriage, creating a new family. The other is just being roommates, living in the same space, but remaining individuals. It's a simple, relatable contrast, but this distinction is the key to understanding the materials all around us. And as we'll see, some of these roommates are very, very good at hiding. This brings us to the deceivers of the material world: homogeneous mixtures. The prefix homo means same, and that's exactly how they appear, perfectly uniform to the naked eye. You can't see the individual components. The most common type is a solution. Imagine dissolving sugar in water. You stir, and the sugar crystals vanish. The water remains clear, and the mixture looks like a single substance. But the sugar molecules are still there, dispersed evenly among the water molecules. They haven't chemically bonded. They're just expertly hidden. That's why the water tastes sweet. Air itself is a solution, a mix of nitrogen, oxygen, and other gases, all blended so perfectly we can't tell them apart. From the deceivers, now we move to the obvious ones. Heterogeneous mixtures. Hetero means different, and in these mixtures, the different components are usually easy to spot. You've already seen simple examples, like that salad or trail mix. But a more scientific example is a suspension. Think of a glass of fresh squeezed orange juice with pulp. When you first pour it, the pulp is swirled throughout. But let it sit for a while. And what happens? Gravity takes over, and the heavier pulp particles slowly settle to the bottom. This is the defining characteristic of a suspension. Its components will separate over time. Muddy water is another classic case. Stir it up, and it's a cloudy brown mess. Leave it alone, and the dirt and sand will sink, leaving clearer water on top. Unlike the perfectly blended solutions or the stable colloids, heterogeneous mixtures are visibly and physically distinct. Here's another, stranger category of heterogeneous mixture: the colloids. Milk is a perfect example. It looks uniform, smooth, and white, but it's not a true solution. It's actually microscopic globules of fat and protein particles suspended in water. These particles are too small to see individually, but large enough to scatter light, which is what gives milk its opaque, white appearance. Unlike a solution, if you shine a laser through a colloid, you can see the beam's path. These are the master illusionists, appearing pure but secretly hiding their mixed nature in plain sight. They don't even try to hide what they are, a jumble of different parts sharing the same container. So, there you have it, the secret recipe of the universe. All matter is organized into two grand families. You have pure substances, like the elemental gold and the chemically bonded compound of salt. And you have mixtures, from the perfectly hidden sugar in your tea to the obvious pulp in your juice. This cosmic flowchart organizes everything you will ever interact with. But this raises a fascinating question. If a rock, a river, and the air are all made from the same fundamental atoms and molecules, why are they so different? Why can some things flow, others hold a rigid shape, and others expand to fill any space? The secret isn't just in the ingredients, but in their energy. And that's exactly what we'll explore next time, as we uncover the four fundamental states of matter. Thank you so much for joining our journey into the universe's pantry. If you enjoyed untangling the fabric of reality with us, be sure to hit that subscribe button and ring the bell so you don't miss our next adventure. Until then, stay curious.